Good day. It is a pleasure to participate in such a fantastic event. Thank you for such an opportunity. Today we will discuss microplastics research trend analysis, the case of tire and road wear particles. Tire and road wear particles are a significant source of microplastics pollution in the environment. These particles are formed mechanically by tires rubbing against the road surface, which enter the air, soil, and water systems. Their impact on the environment and health is still insufficiently researched. Currently, there is a growing scientific interest in this research, and therefore the research question is formulated: what are the main trends in TRWP research? This study is based on an analysis of academic literature, a detailed bibliometric analysis, and a science mapping analysis. The analysis identified clusters dominated by different thematic poles and methodological approaches. The most influential articles were characterized not only by a high number of citations, but also by a significant betweenness centrality and sigma index. First, by using bibliometric visual software tools, BOSS Viewer and CiteSpace, a bibliometric analysis was performed where 106 scientific publications published in 2011 to 2025 from the Web of Science core collection dataset were analyzed. Science mapping analysis included co-citation analysis, co-authorship analysis, bibliographic coupling, and co-occurrence of keywords. Second, major clusters were distinguished, including citing articles and cited references. The importance of nodes will be summarized in terms of citation-based metrics, citation counts, and citation bursts, network-based metrics such as degree centrality and betweenness centrality. Sigma is a combination of both types, i.e. burst and betweenness centrality. Keyword coexistence analysis revealed the most commonly used terms associated with TRWP research: microplastics, tire wear, particulate matter, toxicity, sediment, and zinc. The co-authorship network identified two dominant clusters of researchers, one oriented towards toxicological risk assessment and the other oriented towards particle identification and environmental transport. CiteSpace clustering identified 8 main thematic clusters characterized by strong silhouette values, greater than 0.76, reflecting high thematic coherence. These clusters covered topics such as TRWP source identification equals 25, health risk assessment, N equals 19, urban environmental research, N equals 16, TRWP environmental dispersion and mitigation strategies, N equals 16, fine particle classification, N equals 11, TRWP chemical composition transformations, N equals 9, TRWP monitoring in marine environments, N equals 9, new methodological and experimental aspects, N equals 7. Citation count analysis showed that the most influential publications in the network had high structural importance, centrality greater than 0.10, but did not show bursts equals 0.00, which indicates a long-term, rather than sudden, impact on the research field. Several publications exhibited high degree centrality as the main links in the network, and all top-ranked articles had a sigma value of 1.00, highlighting their important role in connecting established, but emerging, research directions. The results show that TRWP research is expanding rapidly, but standardized methods for particle classification and long-term impact assessment are still lacking. Bibliometric visualizations provide a systematic way to reveal research structures, knowledge gaps, and emerging trends. Thank you for your attention.